so question 3, we've got to this time express this all in terms of sine. Okay, so because we've got some squareds, we're going to be using the sine squared plus cos squared is equivalent to 1. So hopefully you can rearrange to get cos squared in terms of sine. We just subtract sine squared from both sides. Okay, and we simply replace the cos squared in the original with brackets 1 minus sine squared. Okay, so we've got 3 sine squared x plus 4 1 minus sine squared x, and then we expand out the brackets. Okay, and simplify. Okay, so the brackets are really useful just in case we forget to multiply every term by 4. And we're going to use the same idea for the second part. So the second part, we have to express all of this in terms of cos. So this time, we're going to replace sine squared with brackets 1 minus cos squared x. And again, the brackets are really useful so we don't make errors with signs. So this gives us cos squared x minus 1 plus cos squared x, which gives us 2 cos squared x minus 1. Okay, brilliant. Right, let's go straight on to number 4. So 4 is proving some identities. This is question 4, part A, part 1. There's lots of parts. Okay, so we've got to prove that this is equivalent to 2. So we normally start with the most complicated side, so obviously this one. And luckily we've got a nice easy first step. We're going to be expanding out brackets and tidying up. So if you're liable to make a mistake, write out the brackets twice rather than trying to square them in your head, because what lots of people do is just write sine squared plus cos squared, which means we're missing some of the terms. So this is the left-hand side is equivalent to this. I'm going to work from one side to the other side. I'm not going to meet in the middle. We're doing a proof, so we have to show that one thing's equivalent to the other. Okay, right, so let's get expanding. So that gives us sine squared x plus 2 sine x cos x plus cos squared x. And then the next set of brackets gives us sine squared x minus 2 sine x cos x plus cos squared x. Okay, so let's gather together like terms. So we've got 2 sine squared x plus 2 sine x cos x minus 2 sine x cos x. They cancel out, and then we've got plus 2 cos squared x, and then it's like question 2. We can factorize that. And then we can apply our identity that sine squared plus cos squared is 1. So that is 2, which is the right-hand side. Okay. Right, let's look at the second one. So the second one, we've got brackets 2 sine x minus cos x all squared plus sine x plus 2 cos x all squared is equal to 5. So again, the complicated side's the left-hand side, so we're going to start from the left-hand side. And again, we've got some brackets to expand, so we just get on with expanding brackets. And you get marks if you get the expansion correct. Okay. You need a lot of paper for some of these. Okay, so multiplying out the brackets, we've got 4 sine squared x minus 2 sine x cos x minus another 2 sine x cos x, okay, plus cos squared x. And then we've got plus sine squared x plus 2 sine x cos x plus another 2 sine x cos x, so that's 4 sine x cos x. And then we've got plus 4 cos squared x, and then we're going to collect like terms. So we've got 5 sine squared x minus 4 sine x cos x plus 4 sine x cos x. So very similar to the previous one. And then altogether we've got 5 cos squared x. We can factorise. And then we can apply our identity and we get 5. So they were both very similar. Okay, so that gives us the right hand side. Okay. Expand brackets, tidy up, factorise. Use your identity. Right, let's try the part B. So this is question 4, part B. Let's start with part 1 of that. So we've got sine theta tan theta plus cos theta is equal to 1 over cos theta. Okay, so again, it looks like I can do some work on the left hand side. So I'm going to start with the left hand side. And this time, there's no brackets to expand or anything, but we've got sines and coses and tans. There's no squareds, so we're going to use our identity for tan. So we replace tan theta with sine theta over cos theta. Okay, so we could slightly tidy that up, but also we've got a fraction and then not a fraction. If you're faced with separate terms of the fraction, then you try and make it one term. If you've got a single fraction term, you try and split it into several pieces, a bit like with logs. Okay, so this gives us sine squared theta over cos theta, and then if I want to make this a fraction over cos theta, I'm going to multiply the denominator, which is currently 1, by cos theta, so I need to multiply the numerator by cos theta as well. And then hopefully you've spotted sine squared plus cos squared, which gives us 1 over cos theta, which is the right hand side, so we're happy. Okay, right, let's try the last one. So this time we have got cos squared theta over sine theta. We've got to show that is equivalent to 1 over sine theta minus sine theta. Now this time this is kind of reasonably tidy, whereas here I know I've got a fraction. I know I can try and make that over common denominator, so I know where to start with my right hand side, so I'm going to start with the right hand side, and you can do that and work your way to the left, all in one direction now. So right hand side, we're going to try and have it over a common denominator of sine theta. Okay, so pretend that this second term is just over 1. So the first term is just 1, and the second one we need to make the denominator sine theta, so we multiply top and bottom by sine theta. And then hopefully this is ringing some bells, because we know that sine squared theta plus cos squared theta is equivalent to 1. So 1 minus sine squared theta, if we subtract sine squared from both sides, we get cos squared theta. Okay, so we've got cos squared theta over sine theta, which is the left hand side, which is what we want.